NASA's Earth science missions help us to understand our planet's interconnected systems from a global scale down to minute processes. NASA Earth Science delivers the technology, expertise, and global observations that help us to map the connections between our planet's vital processes and the effects of ongoing changes. A multitude of data is collected to fuel this research. This data is freely and openly available to anyone. There are 4 program elements of the Earth Science Division. The Flight Program builds and operates the missions that deliver critical measurements and data to the world's science community. This program manages scientific investigations and oversees data centers that manage information to support Earth science research worldwide. NASA's Research and Analysis Program advances our scientific understanding of Earth as a system and its response to natural and human-induced changes in order to improve our ability to predict climate, weather, and natural hazards. The Applied Sciences program helps partners use NASA's unique view from space to address real-world issues. The program works with individuals and institutions to inform decision-making, enhance quality of life, and strengthen economies, building meaningful partnerships to power innovative projects using NASA data. NASA's Earth Science Technology Office funds and develops a broad range of technologies for the scientific observation and measurement of Earth. These technologies are also used for NASA operational requirements, as well as practical applications that benefit society. NASA gathers information about the Earth from a huge fleet of Earth-observing satellites, shown here. This slide shows the operating satellites in blue and green, those in development in purple, and those in planning stages in yellow. NASA Earth Science oversees data centers known as Distributed Active Archive Centers, or DACs. DACs are dispersed around the country and archive 16 terabytes and distribute 32 terabytes of information products each day. The Earth Observing System Data and Information Systems, or EOSTIS, acquires, preserves, and distributes data from spacecraft and field campaigns to support Earth science research worldwide. NASA's Earth Science Data Systems Geographic Information Systems team was created to provide a sustained support across the program to enable the appropriate use and adoption of GIS technology in support of Earth science research and applied science. NASA's Earth Data GIS content is making NASA's free and open Earth science data interactive, interoperable, accessible, and GIS-enabled through primary GIS tools and platforms.
Worldview is a visualization application that provides the capability to interactively browse full-resolution satellite imagery layers and then download the underlying data. Many of the available imagery layers are updated within 3 hours of observation, essentially showing the entire Earth as it looks right now. You can add layers via hazards and disasters thematic areas or by science disciplines. NASA's ArcGIS Online links to publicly available content, such as web services, applications, and story maps. Selected content is also being nominated to Esri's Living Atlas of the World. The Living Atlas now features 12 imagery layers provided by NASA Earth Data that visualizes data collected by several NASA instruments. The application for extracting and exploring analysis-ready samples, or APPEARS tool, from the Land Processes DAC offers a simple and efficient way to access and transform geospatial data from a variety of federal data archives. APPEARS enables users to subset geospatial datasets using spatial and temporal and band layer parameters. 2 types of sample requests are available: point samples for geographic coordinates and area samples for spatial areas via vector polygons like I did here. LPDAC is utilizing an ArcGIS server to enable single point of access to all services, distributing a wealth of data. The Socioeconomic Data and Application Center provides a web-based service for estimating population totals, basic demographic characteristics, and related statistics within a user-defined region. This service accepts polygons that define areas of interest. The service then returns population totals based on user-selected variables, one or many out of more than 100 possibilities, and basic parametric statistics. They also have a web mapping tool that enables visualization of all CDAC map layers. The CDAC map viewer organizes the map layers into approximately 15 interdisciplinary topics or themes that users can select. Users may also zoom into a region of interest using a selection list in addition to typical pan and zoom options. The Alaska Satellite Facility DAC focuses on synthetic aperture radar, or SAR data. Vertex is their search tool, as you see here, which allows for the preview of numerous types of SAR data, including Sentinel-1. Vertex also offers on-demand processing of radiometric terrain correction. And then if you go back to their site, they have several data recipes and an ArcGIS Python toolbox for integrating and analyzing SAR data in a GIS. Here we have an Esri story map created by NASA's Global Hydrology Resource Center DAC to show how DISI, the disdrometer, participated in the Global Precipitation Measurement, or GPM, ground validation field campaigns. This story map is a fun and interactive way to learn about the disdrometer instrument, the GPM Ground Validation Project, GHRC, the different field campaigns performed during the project, and where the reader can find these data. Giovanni from NASA's Goddard Earth Sciences Data and Information Services Center is a web application that provides a simple, intuitive way to visualize, analyze, and access Earth science remote sensing data, particularly from satellites, without having to then download the data. You can specify a date range, a region of interest, a particular measurement. I can select that measurement and plot my data. The tool provides subsetted data downloads in GIS-ready formats, such as GeoTIFF, KMZ, and PNG files, which means you do not need to learn data formats to retrieve and process data. There are multiple visualization and statistical analysis functionalities and various maps and plots served through a WMS protocol. GESTIS also provides data from the Global Precipitation Mission, or GPM's, Integrated Multi-Satellite Retrievals for GPM, or iMERGE, and the Famine Early Warning Systems Network Land Data Assimilation System. These are globally used data to study hydrological cycles and extreme events such as drought, tropical storms, and landslides. Here you are seeing a story map that they did on Cyclone Amphan. The Oak Ridge National Laboratory DAC Spatial Data Access Tool, or SDAT, is an open geospatial consortium standards-based web application to visualize and download spatial data in various user-selected spatial temporal extents, as you can see here. You can also decide on a particular file format, projection, and so forth. Several data sets that are included are land cover, biophysical properties, elevation, and other archive data. KMZ files are also provided for data visualization in Google Earth. The Physical Oceanography DAC's State of the Ocean, or SOTO tool, is an interactive web-based tool used to generate maps, animations, and plots that communicate and promote discovery and analysis of the state of the ocean. It provides access to a broad range of satellite-derived products and key parameters of interest to the oceanographic community. SOTO enables research through exploration and comparative analysis of physical oceanographic data. The Surface Water Ocean Topography, or SWOT mission, is a future satellite mission planned for launch in early 2022. The mission will be NASA's first global survey of Earth's surface water. SWOT is actively preparing surface water datasets for GIS visualization and analysis capabilities with their framework for data ingest, assembly, and web service distribution. These datasets will be available via the PODAC. The Fire Information for Resource Management System, or FIRMS, is a joint effort by NASA and the U.S. Department of Agriculture Forest Service to provide access to low-latency satellite imagery and science data products to identify the location, extent, and intensity of wildfire activity and its effects. These tools and applications provide geospatial data, products, and services to support strategic fire management needs of U.S. and Canadian agencies and to inform the public. These include active fire detections like we're seeing here from satellite imagery and other relevant data, and active fire data downloadable in various GIS formats. Satellite imagery accessible from web map services or from the Global Imagery Browse Services, or GIBS, and email text fire alerts for new fire detections within defined areas of interest. All of these are provided by NASA's Earth Observing System Data and Information System.
The Applied Sciences program supports partner organizations and research scientists who are using Earth observations to solve the world's toughest challenges. From local communities to national governments and across every region of the world, our collaborative projects have outsized impact. The program's focus areas include capacity building, disasters, ecological forecasting, food security and agriculture, health and air quality, and water resources. The Disasters Program of NASA's Applied Sciences improves the prediction of, preparation for, response to, and recovery from hazards and disasters around the world. The disasters team coordinates with decision makers and local governments, providing actionable data to recover from disaster impacts and build resilient communities. The disasters team creates event-based products such as this, where the Multi-Angle Imaging Spectroradiometer, or MISAR team, provided this map of wildfire smoke plume heights for the Australian bushfires. The different camera angles from the satellite provide different views used to derive the height of the smoke plumes. The plume point heights are exaggerated to better show the structure of the plumes. Having both accurate and current data during a disaster is critical. The NASA Disasters team has enabled many near real-time web services to provide users with regularly updated content, with some data products posted approximately 2.5 hours after observation from spacecraft. This example is from NASA's Soil Moisture Active Passive mission, or SMAP. This allows us to detect how much water there is in the surface layer of the soil. This layer is made available with a refresh of every 3 days. This actual soil moisture values represent how much water there is in the surface layer of the soil profile, with brown indicating low or dry soil moisture conditions and green indicating high or wet soil conditions. The disasters team creates a wealth of resources to understand and respond to a multitude of events. The example here identifies damage from Hurricane Dorian. To understand the unique value of synthetic aperture radar, or SAR, in combination with geostationary imaging, a spyglass tool reveals potential flooding detected by the Sentinel satellite by seeing through Hurricane Dorian. Using the spyglass tool, users can take a peek beneath the clouds and see where NASA has identified potential flooding in blue. NASA's Earth Science and Remote Sensing Unit at Johnson Space Center uses GIS to georeference astronaut photography for use in disaster response. This photograph was taken by astronauts aboard the International Space Station in July of 2020 and documents a flooding event in Colombia, South America. NASA's prediction of worldwide energy resources, or power, was initiated to improve upon the current renewable energy datasets and create new datasets from new satellite systems. Power provides geospatially enabled, analysis-ready data ranging from 1981 to the current date and consists of over 275 meteorology, and solar energy parameters at 4 temporal levels. The Data Access Viewer supports the data download of data products from Power's ArcGIS image services and the API through a simplified user interface. NASA's Applied Remote Sensing Training Program, or RSET, offers satellite remote sensing training that builds the skills to integrate NASA Earth science data into an agency's decision-making activities. Trainings are offered in air quality, climate, disaster, health, land, water resources, and wildlife management areas.
We understand NASA data is complex and you might be feeling overwhelmed. To help you get started with learning about using NASA data and GIS tools, the following are great resources. Created to celebrate International GIS Day, this story map introduces GIS at NASA Earth Science, using data, maps, and applications to demonstrate the benefit GIS provides to both the scientific community and the world at large. The resources provided in the following slides can also be found in the Getting Started section of the story map. Earth Data's GIS page provides an overview of NASA-curated tools and resources and links to the NASA Earth Science GIS Wiki. This is a place where readers can find tutorials and data recipes related to GIS, open source GIS software, and the Esri suite. Are you new to using NASA Earth Science data? If so, these data pathfinders are the perfect place to start. Pathfinders are designed to help guide you through the process of selecting data, products, and learning how to use them. Data Pathfinders provide direct links to commonly used datasets across NASA's Earth Science data collections. They are intended to familiarize users with various datasets that are applicable, with some guidance on resolution, whether that be spectral, spatial, or temporal, and to provide direct links to the data sources. After getting started here, numerous NASA resources can help develop your skills further. Pathfinders are available for several key themes, from agriculture and water resources to biological diversity and ecological forecasting, COVID-19, disasters, geographic information systems, health and air quality, sea level change, wildfires, and more. A Pathfinder specific to GIS was developed to provide a guided walkthrough of NASA data and GIS tools. This resource provides links to the tools from which data can be visualized, subset, and downloaded in different file formats, as well as a brief tutorial on using web services to access NASA data. Data toolkits are designed as entry points to access NASA Earth Science data resources organized by topic. They contain links to datasets, tutorials, and how-tos, feature articles, and data user profiles, as well as other useful information. NASA Earth Data Discovery, and Data Access webinars span the Earth Science disciplines and are designed to help users learn about NASA EOSDIS data, services, and tools, and show users how to work with these data resources. The Earth Data Forum is a new tool developed to engage subject matter experts from several NASA DACs to discuss general questions, research needs, and data applications. Here you have the capability to search by discipline, DAC, major projects, and services or usage. Users can query how to access, view, and interpret the data, alleviating time and energy of working with complex data and focusing instead on the research and analysis aspects of science. NASA offers petabytes of global Earth science data collected from satellites, but accessing these data in a traditional or virtual science classroom can be tricky. Since 2004, My NASA Data has supported students and teachers of grades 3 through 12 in analyzing and interpreting NASA mission data. The My NASA Data team strives to support your integration of authentic Earth data in your instruction. GIS is heavily featured in this content, including a diverse set of comprehensive story maps used to communicate science to various grade levels.
All things Earth Science can be found on NASA's Earth Science webpage. Here you can learn about our missions, find tools to access the data, identify a multitude of resources available to help you get started, and see how NASA is helping to address challenges facing our planet. So what are you waiting for? Come explore with us.